All right, this video is going to go over lesson 3.10 notes, talking about solving systems of equations. By solving a system of equation, it means we're going to find all ordered pairs that make both of the equation true. So notice that our answer is an ordered pair, which is xy, that makes our equation true. So for example, if we have a system of equations, that's two lines together. So if two lines are going together, we have three different options. First option is they can cross. If two lines cross, something like this, or they intersect at this one point. So this one point would be our one answer. We would have one solution. So that's option one. Option two, what if they're parallel? Meaning parallel lines never touch. So if they're parallel, that means they never touch, so no solution. They run parallel. Our last option, what if we have a line and the other line is exactly on top of it? So they're two overlapping lines. In this case, they intersect at every single point, going on forever in both directions. So this means infinitely many solutions. So every single point going on forever on that line will be a solution, will be an answer. So our first example, for each ordered pair, determine whether it is a solution to this system of equations. Our system is 6x plus 7y equals -5. That's our first line. Our second line is 3x minus 2y equals -8. So they give us ordered pairs here. They give us x comma y. They give us x values and y values. We're going to plug it in, and remember that they have to make both equations true. So we're going to plug it in, and it's going to, if it works for both of them, it'll be yes, a solution. If it does not work for either one, then no, it is not a solution. So let's start off. So 6x plus 7y equals -5 is our first equation. Our first point says x is +5, y is -5. So plugging that in. So 6 times +5 plus 7 times y, which is -5. And does that equal -5? Let's see, 6 times 5 will give us 30. 7 times -5 will give us -35. Does that equal -5? Let's see, 30 minus 35 is -5. -5 equals -5. Yes, that works. So it worked for the first line. Let's try the second line. So 3 times x minus 2y equals -8. So plugging in 3 times x is 5, minus 2 times y is -5. And does that equal -8? 3 times 5 is 15. -2 times -5 is +10. So 15 plus 10 is 25. 25 does not equal -8. So because that does not equal, this is not a solution. It does not work with that second line. Same thing for plugging in 7 and 3. So starting off, 6 times x, so 6 times this time x is 7, y is 3. So 6 times 7 plus, going back to our equation, 7y, so 7 times 3. Does that equal -5? Let's see in our calculator. Let's just plug it in here to save some time. 6 in parentheses 7 plus 7 in parentheses 3. That will give us 63. 63 does not equal -5. So this one does not work. So I don't have to try the other equation because this one didn't work. So that means it can't work for both. So that means our answer is no. Next, trying the point -1, 2. So x is -1, y is 2. Going back to our original 6x plus 7y equals -5. We're going to plug in -1 for x. We're going to plug in 2 for y. So 6 times -1 plus 7 times 2. Does that equal -5? Let's see in our calculator. 6 times -1 plus 7 times 2. Oops. We get 8. 8 does not equal -5. Again, this does not work. So because it doesn't work for that first one, it doesn't even matter if it worked for the second one or not. It cannot work for both. Last but not least, -4, -2. X is -4, y is -2. Plugging into our equation. 6x plus 7y, does that equal -5? That's the question. Plugging in -4 for x and -2 for y. We get 6 times -4 plus 7 times -2. Does that equal -5? Let's see. 6 times -4 plus 7 times -2. -38. -38 does not equal -5, so no, that does not work. Same thing, don't even have to check the last one, the other equation, because it doesn't work. If they worked for both of them and were true for both, then our answer would be yes. So, next example. So we've seen, is it a solution or not? Now actually going through and trying to find this system of solutions. We're going to look at a couple of different ways to find this. Our first way we're going to do is graph both lines and see what happens. So we're going to graphically find the system solution. So in order to find the solution of a system, remember that's the order pair xy where these 2 points cross, which is the point of intersection. So here we have 2 lines. What is our solution? Our solution's right here where these 2 lines cross or intersect. This ordered pair is over 1, up 3. So this ordered pair is 1, 3. So our solution here is 1, 3. So the last thing we're going to look at on our next page is solving it algebraically. So that was solving it graphically. Now we're going to solve it algebraically. A couple of different options here. We're going to talk about in this class, just to kind of keep it simple, we can do this for every single problem, is the substitution method. We're going to substitute in one variable or the other. So before we even get into this, notice a system of equations has 2 lines in it. For each line, we have 2 variables. That means if I have 2 variables, I can't solve for one of them and get x equals some number or y equals some number because there's too many unknowns, there's too many variables. So what we're going to do is we are going to find only one variable first, substitute that in for the other variable, and then go from there. So we are going to solve for one variable. We can do either x or y, totally up to you. You'll get the same answer in the end, either x or y. Now we're going to take that x equals or y equals. So x equals or y equals. We're going to take that x equals or y equals and substitute or plug it into the other equation. And then we're going to solve, and then we're going to substitute again. Let's try one. Solve the system of equations. Y equals 9x and y equals 2x plus 56. So for our first equation, it already has y equals 9x. It already solved that y equals, it already solved for that one variable, that first step for us. So now instead of y for our second equation, I know y is the same thing as 9x. So in this y equals 2x plus 56 equation, instead of y, because I only want to get x's here, instead of y, I know y is equal to is the same thing as 9x. So instead of y, sorry, I keep on hitting it. Instead of y, I can write 9x. Because y equals 9x, y is the same thing as 9x. And then just bringing all this stuff down. So 9x equals 2x plus 56. Now we're golden. Now we only have x's. We can do this all day long. We can solve for x. So that means we want to get our x's together and combine like terms. I want to bring this positive 2x over here with that 9x. So I'm going to subtract 2x from both sides. 9x minus 2x will give us 7x. Equals 2x minus 2x cancels each other out, so equals 56. So 7x equals 56. Getting x by itself, it's 7 times x. So we are going to do the opposite. We are going to divide both sides by 7. That means 7 divided by 7 will go to 1. 1x, which is just x, equals 56 divided by 7, which is 8. Boom. We know half of our ordered pair. We know x equals 8. Now that we know x equals 8, I can plug in x equals 8 to either equation and get y by itself now. So let's plug x equals 8. Let's just pick the first one. The first one looks smaller. So y equals 9x. So now we know x is 8. So y equals 9 times 8. Taking this x equals 8, plugging it in over here. So 9 times 8 will give us 72. So y equals 72. Boom, our answer is the ordered pair x comma y. X is 8, y is 72. So these two lines will intersect at the ordered pair 8 comma 72. Done. Let's do 2 more examples of this. Use substitution to solve the equation 3x minus 5y equals 7 and 3y plus 1 equals x. So again, this second equation already has x by itself. It says x equals 3y plus 1. X is the same thing as 3y plus 1. So instead of x to our first equation, we can write instead of x, 3y plus 1. So 3, instead of x, we know x is equal to is the same thing as 3y plus 1. And then going back to our equation, minus 5y equals 7. So notice we have the same first equation, 3x minus 5y equals 7. But now instead of x, we know x is the same thing as 3y plus 1. So now we have an equation with only y's in it. We can solve for y. So in order to solve this, we're going to first distribute. 3 times 3y will give us 9y. 3 times positive 1 will give us plus 3. Bringing down minus 5y equals 7. Combining like terms, 9y minus 5y will give us 4y. Plus 3 equals 7. Combining like terms, let's bring that positive 3 over with that 7. In order to get rid of that positive 3, we're going to do the opposite. We're going to subtract 3 from both sides. That means we're left with 4y. 3 minus 3 goes to 0, so it cancels out. 7 minus 3 will give us 4. Last but not least, getting y by itself, it's 4 times y. So we're going to do the opposite. We are going to divide both sides by 4. 4 divided by 4 goes to 1. It cancels out. So we're left with 1y, or just y, equals 4 divided by 4, which is 1. Halfway done. Halfway done. Now we need to see what does x equal. Plugging it into either equation. I'm looking for x equals, so I'm going to plug it into this bottom one because it's already kind of x equals. So we have 3y plus 1 equals x. We know our y value is positive 1. So 3 times 1, because we know y is 1, plus 1 equals x. 3 times 1 is 3. 3 plus 1 is 4. So 4 equals x. Whoa. So our ordered pair, our solution is the ordered pair x comma y. X is 4, comma y is 1. So our final answer is 4, 1. Last page, we have one more example, exactly like this. Solving the system of equations. We have y equals 4x plus 11 and y equals x plus 38. So now we're looking for x equals or y equals. In this case, they are both y equals, so it doesn't really matter. It's kind of like that first example that we did. So we know y is the same thing as equal to x plus 38. So in our first equation, instead of y, we can plug in x plus 38. So instead of y, we're going to plug in x plus 38 equals 4x plus 11. So notice our first equation was y equals 4x plus 11. But instead of y, we rewrote it, we substituted it for x plus 38, because the second equation tells us that y is the same thing as x plus 38. So I can rewrite them interchangeably. It's kind of like synonyms. Like you can say, oh, I'm not very good at synonyms. I'm just finding out on the spot. If you say something, oh yeah, that test was really hard. Instead of saying the word hard, you can say the word difficult, you can say the word challenging, you say the word complex, and they all have the same meaning, just different words that have the same meaning. Same thing here, it's kind of like synonyms. They have the same meaning. Y means the same thing as x plus 38, so we can use them interchangeably. So now we have an equation with just x's in it. X plus 38 equals 4x plus 11. So we can now solve for x. Combining our x's together, we have this 4x. Let's bring it over here with this 1x. It's positive 4x, so we're going to do the opposite. We are going to subtract 4x from both sides. That way 4x minus 4x goes to 0 and cancels out. We are left over with 1x minus 4x's will give us negative 3x plus 38 equals 11. Still combining like terms, let's bring this 38 over here with this 11. So we are subtracting 38 from both sides. It's positive 38. So 38 minus 38 goes to 0 and cancels each other out. We're left over with negative 3x equals 11 minus 38. In your calculator, 11 minus 38 will give us negative 27. Dividing both sides by negative 3, it's negative 3 times x. So in order to get rid of that negative 3, we're going to do the opposite. We're going to divide by negative 3. That way, negative 3 divided by negative 3 is 1. We're left with 1x, which is just x, equals negative 27 divided by negative 3. In our calculator, if this confuses you, oops, down here, negative 27. So negative 27 divided by, again, negative 3 equals positive 9. So x equals positive 9. We're halfway done. We got the x value. Now all we need is the y value. So I can plug in x equals 9 to either one. Doesn't matter. Second one looks easier. So let's use y equals x plus 38. Instead of x, we know x is 9. So we know y equals 9 plus 38. In our calculator, 9 plus 38 is 47. So y equals 47. Our final answer is the ordered pair x comma y. X is 9, y is 47. So our final answer is the ordered pair 947. If we were to graph these two lines, they would intersect at the point 947. Extra credit. So for the extra credit test review, just like every other test, there is one that's made on ALEX now. Before there wasn't one on ALEX. So that's why this is from the textbook. I highly recommend the one from ALEX, just so that way you're used to ALEX more and it'll look more similar to the actual test. But you're welcome to do this one as well in your textbook and still get extra credit either way. But like I said, I highly recommend the ALEX review for test 3. So that is all of 3.10. If you have any questions, please let me know. If not, I will be talking to you. Thanks for watching.